Hi, my presentation is on neutron stars. This is what neutron stars look like. This one on the right here looks like two neutron stars colliding. We'll get to that later. Neutron stars are 95% neutrons. When protons convert to neutrons, they release ubiquitous particles called neutrinos. Neutron stars are made in supernova explosions, which are giant neutrino factories. From symmetrymagazine.org. Neutron stars are kind of like planets in a way, because they have an atmosphere, a crust, and a core like Earth does. The crust is made up of iron nuclei, and nobody really knows what the core is made up of. But I watched this video down here by Kurt's Gazette, and it said that that protons and neutrons could dissolve into seas of quarks. Neutron stars. When the core of a massive star undergoes gravitational collapse at the end of its life, protons and electrons are literally scrunched together, leaving behind one of nature's most wondrous creations, a neutron star. Neutron stars cram roughly 1.3 to 2.5 solar masses into a city-sized sphere, perhaps 20 kilometers, which is 12 miles, across. Matter is packed so tightly that a sugar cube-sized amount of material would weigh more than 1 billion tons, about the same as Mount Everest. That's from NASA. Here are more pictures of neutron stars. Neutron stars don't really die, but they emit radiation until they get colder and colder. They usually crash into each other, though. They spin around each other and they get faster as they go around each other. They get faster as they get closer to each other until they crash. The energy from their spiraling and merging releases energy in the form of gravitational waves, or ripples in space-time, from nationalgeographic.com. When two stars crash into each other, they either make a more massive neutron star or they can make a black hole. This is what the collision looks and sounds like. This is the first time scientists have directly detected gravitational waves, ripples in space and time, in addition to light from the spectacular collision of two neutron stars. This is what they got. This marks the first time that a cosmic event has been viewed in both gravitational waves and light. So, I don't have the premium version of my screen recorder, and so you can't hear computer audio. But basically, as the two neutron stars are circling together, it makes kind of this low buzzing sound, and as they get closer and closer, the sound gets higher and higher. And when they finally collide, I don't know, it kind of sounds like a water droplet hitting a pool of water, you could say, I guess. So, yeah. All neutron stars used to be a massive star. Once the massive star runs out of fuel and collapses, every proton and electron is crushed together to make a neutron. Stars with higher masses will continue to collapse into stellar mass black holes, from NASA. Neutron stars can get to 1 million years old before they lose all of their radiation. Neutron stars are only detectable with modern technology during the earliest stages of their lives, almost always less than 1 million years, and are vastly outnumbered by older neutron stars that would only be detectable through their black body radiation and gravitational effects on other stars. From Wikipedia. Well, that concludes my presentation. Thanks.